Hello, everyone. Thanks for joining. I hope you can hear me well. If not, please say so, and I'll try to fix my settings. So I'm going to share my screen. And data flows. So just to know, I mean, I don't know all the people that joined, but anybody want or need some introduction to data packages? If you do, just say so, and I'll give a 5-minute introduction. Okay, so I guess not, which is good. So I want to talk about Data Factory and data flows, and there's a blog post that we published a couple of weeks ago about that, and I'll try to summarize it in a few sentences. So, as you all know, data packages are a very neat way of packaging data. So you take some piece of data, maybe one resource, maybe a couple of resources, and you add some metadata. And you have this very cool standard, which is very usable, very portable, to capture all that data and to basically reuse it. But data packages are in fact static data. So the data packages, the data package standard, sort of captures how we take data that's at some sort of a snapshot of data that's true for some point in time, and we package it. And when we started thinking about Data Factory, we started to think about how to standardize data packages that are in transit. So in transit could be we want to take a data package from a certain location, move it to another location. Could be from maybe not really a data package, but maybe an Excel sheet, which is a representation of the data, and maybe we want to move it using a data package and then eventually put it up in a database. So that's data package that's in transit. And another aspect of being in transit is also modifying the data package in various ways, maybe adding a resource, maybe combining two resources together, maybe doing some verification on the data package. So it's basically a more dynamic aspect of the data. And this is the concept that's behind Data Factory. And before I dive more deep into that, I want to share a bit the history of this and how it came to be. So I've been in the scraping business for I think almost a decade now, unpaid mostly, and I mean I've been working a lot with fiscal data. Some of it from Israel, which is where I live, and some of it is from the rest of Europe, which is done partly with my work with open knowledge. And what I came to understand was that when we're talking about taking data and scraping it, or in the more technical term, using an ETL and extract transform load software, it seems that the needs that the open data world sort of requires are very different from the ones that are more common, let's say, in the commercial world. So when you talk about commercial entities, usually they deal with large amounts of data, what you would call big data, and they often work with streams of data, like streams of events, streams of I don't know, call logs, or streams of ad clicks, whatever. So they have a very specific and very common working point that sort of all of the tools are optimized around that. In the world of open data, the data is not that big. A budget file or even spending files. I mean, the files are often files that we can normally put on our laptops. And so often you would find that the tools that are in the that are more common in the commercial world are a bit too powerful, too powerful for our own good, and we needed something simpler. Another reason we wanted something simpler was because we would often work in communities of contributors, and these contributors were sometimes volunteers, sometimes people who just want to come in and contribute a bit in the open source fashion. And for that use case, what we wanted to optimize on wasn't necessarily the feature set of the tool, but its simplicity, the ability to understand what's going on and to have maintainable data pipelines that are easy to understand, easy to change, and easy to review. So with these two requirements in mind, and with a project that was called EU subsidy stories, which was meant to take all the different subsidies data from all around Europe and to combine them into one database, we started working on a project called Data Package-Pipelines. And the idea the Data Package-Pipelines came up with was to formalize data pipelines. And here I'm showing something on my screen finally. So instead to do data processing, we created sort of a formalistic language that you would define in a YAML file, not in code, but in sort of a configuration file. And that language was used later to do 90% of the common tasks that you always get to doing in processing data. So, for example, here we have what I'm highlighting right now is an example of a data package pipelines pipeline specification. So we start. This is the pipeline, and it's bringing us CO2 emission data from the World Bank API. And we're first starting by setting the metadata for the pipeline. Then we're loading the data from the API. We're setting the types in the schema, and finally we're saving the data into a zip file. And this is already a data package. So this is sort of a very simple transformation from an API into a data package. And some pipelines look like that. I mean, they were taking data from an external source and converting into a data package. And some pipelines would take a few of those intermediate data packages and combine them together, maybe doing some analysis, maybe adding more columns, enriching the data packages to create eventually the one big final data package that contained all the subsidy data. And this was great, and the big thing about it was that, again, 90% was done in these YAML files, and when you had a very specific task that wasn't sort of covered with these generic building blocks, you could still write a Python script that would just do that small bit or small modification or small customization to the data, and that way we would reduce greatly the boilerplate, and everyone working on the project could read these YAML files because they would use the same language. It would be the same steps. Everybody would know what update package is, and everybody would know what load is. And this framework called Data Package Pipelines proved to be very useful in various other scenarios because of the maintainability. And even though it wasn't tailored for terabyte data processing, it was very useful in working with heterogeneous sources and combining these sources together into data packages. So this is the story of data package pipelines, and if you have any questions so far, I can answer them. Because now I'm going to talk about data flows and how this was born. Okay, so if you have any questions, then don't hesitate to interrupt me. So DataFlow is relatively a new library. I've been working on it in the past few months, and it came out of actually from an issue in data package pipelines asking, I mean, wow, these processors are really cool. I mean, data package pipelines has concatenate and join and unpivot processors. I want to use them in my script. Can I use just the unpivot functionality in my script? And the answer was no. I mean, you have to run it inside the data package pipelines framework, which includes a lot of stuff besides just the processors. It has a very specific running execution model using multiple processes and specific streams. So no, you can't use it externally. But then I started thinking, I mean, why not? I mean, this is really a good idea. So then I started working on basically taking out these processors out of data package pipelines and creating a library that just had this functionality, a Python library that was only meant for this sort of data processing or let's say data package processing. And eventually we integrated it back into data package pipelines. So now data package pipelines doesn't have its own processors. It relies on data flows. And you can use these processors outside of data package pipelines in data flows, as I'll show you in a second. So let's dive a bit into data flows, and I'll just give a comment about Data Factory. So Data Factory is the concept that sort of guides all these efforts. But it's still it's still a concept. I mean, in the same way that frictionless data is a concept. And when we're now sort of playing with these different standard processors and understanding what sort of processing you need to do on a package, and eventually I hope that this will be sort of formalized into something more concrete and more standard. That will be the Data Factory standard. But at the moment, it's just more of a concept that says we have the processors, we have the definition of what is a data package stream, not just a packaging static data package, but a package in motion, and starting to think about these concepts together. And you can read more about it in the blog, but because it's abstract, I don't want to bore you too much. So data flows. I think it's best to work with examples because everybody loves examples. So if you go to DataHQ/DataFlows, you find the link to the tutorial, and the tutorial is an online IPython notebook, which is, and if my internet works great, then the tutorial will work great. So let's start with the simplest hello world example. And here, please just stop me whenever you have any questions, because otherwise I'm just going to keep on talking. So this is the basic API. You have this class called flow with a capital F. And this class just accepts parameters. Each parameter is just a step in processing. So what is a step or a processing step? So a processing step could be just a list of dictionaries. So in this example, first step is called data. Data is just a list of dictionaries. So this would be the input for our flow. Then we have another step which is called lower data. Lower data is a function. So this function accepts a parameter called row and just modifies it. So in this case, it takes the data in the row and just lower cases it. And when we take a look at the results, this is what we get. So we see that the hello and the world were lowercased. Yeah. Okay. and this is a very simple example. So we have this flow. The flow takes the data, applies the function, and returns the results. Results, apart from returning the data, it also returns a data package. So we have a data package. We have the data itself. And later I'll show you how we can actually save that data package into a disk or other destinations. Okay, so any questions so far? Let me check the chat. So back to the tutorial. Okay, so now we've seen that we can have data as a source. We can also have, so load is a quite versatile processor. It can load from various sources. You can give it a file name. You can give it a URL. You can give it a Google Doc. You can give it a data package. You can even give it a descriptor and the data of the data package in a Python object. So pretty much whatever you give it, it will try to load it. If it's not a data package, then it will also infer the schema for the data, and it can also cast it. So if you, for example, pass it a CSV, it will also try to cast the data. You can disable that function. That's if you want, but it will basically take the data and do the best it can to extract it and get you something workable. So let's take a look at this second example. We have the load. We have title name, which is a function that basically just title cases the name. And this is the CSV file, by the way. So it has a name and an instrument. And we end up with a list of dictionaries with name, with a title case, and an instrument. So we've seen loading from memory. We've seen loading from file. But we don't have to load from the source to be a generator, Python generator, which basically yields the data, but it doesn't hold the data at any point. So if you take a look at this example, which is a bit complicated, you can see the screen, okay. So this example basically opens a Wikipedia page and iterates over it, and whenever it finds specific HTML element, it just yields a dictionary. So it doesn't have any list of data. It doesn't, I mean, the data is not stored anywhere, but it's still a valid source, and I can just pass it here, and I can print it. Yeah. So I have another process called printer, and it will just print it, and you can see that we have the data. Now, one of the things you can see here is that the population is detected as string, and that makes sense because it has these commas, and we can't really know for sure exactly how to handle commas in the data. So it's inferred as a string, but we want to make sure that it's parsed as a number. So we just set the type for that column. We said, okay, set type population to be number, and we give it a group char, which is basically the group separator for numbers, to be the comma. And again, we can just give a lambda function here as another processor which just takes the row and adds and modifies the population. Here it just divides it by 1 million, right? And the data is already correct. Number, it was parsed correctly, and we can see that it's really a number. It's not a string anymore. So we just keep on adding processing steps to the flow, and the flow will just run and do its thing. Now, behind the scenes, what flow does is taking the data and processing it row by row. So it does it in a processes it as a stream. Now, this is really useful when you're working with larger data sets, because at no point it actually loads all the data into memory. It does everything it can to keep a very low memory footprint, which means that you can work with the data flows on relatively small machines, but also that you can work with samples of data, and you can be very confident that when you go to the actual data set, it won't blow up your memory. Okay, so this is so, and now saving data into just dump the data package into a path. We can also use something called dump to zip, which is very similar, except that the data package is stored in a zip file and not just as a JSON plus CSV files. So you could say, okay, so processing is done in a stream, but eventually, if we go back to memory, so we didn't really achieve anything. And you're right. Flow has two operation modes. You can call results, which will basically get you the results. So it will load all the results into memory. But you can also use flow process, which will just get you the data package without data itself. So it will do all the processing, and if you can print the data, you can dump it to a file, put it into memory. So everything will be done as a stream. You can still work with the data package afterwards, but you won't load the data into memory. Next, okay. Hokku, which is basically a flow that sort of finds all the Pythagorean triplets, so all those integer triplets that's that's for them a squared plus b squared equals c squared. So we start by creating a generator that just yields all these triplets. This is the first step of the flow. We set the types for them to be integers. We run a filtering function. So this is a function that we haven't seen so far. It's a function that iterates on all rows, checks for a specific condition. In this case, row a squared plus b squared equals c squared. So if this holds, then it yields the row. So this basically filters out any row that doesn't fulfill this condition, and eventually just dumps the data to the path and also prints it. And you can see that we have 3, 4, 5, which is like the most famous one, and others, 6 in total. And I mean, the cool thing here is that, I mean, how does Flow knows that this function is supposed to work on the entire set of rows, whereas the function here, let's say that we saw in the beginning. And the answer is that DataFlows looks at the signature. Any function that accepts a parameter called row will just get one row at a time. Any function like this one parameter, DataFlows will pass it iterators of rows. So if a data package has one resource, it will be called once with that iterator for that specific resource. And if it has multiple resources, it will call it a couple of times, each time with a single resource's data. But we also have a third kind of function, and let's show an example here. So let's take this example. We work with the same CSV before that had the names and the instruments columns, and we want to add another column called isGuitarist, which basically is a Boolean value holding true if it's a guitar and false if it's not a guitar. So this example is a bit complicated, but it just sort of shows you how it could be done. It's not how it should be done. So this function takes a package and it does first manipulation of the schema. So you can just manipulate it directly. You call the package descriptor and add another field to the schema. And you yield that from modify each one of the rows in the resources. So basically, you have quite a lot of control here. You can modify both the data package and each part of the data as much as you want here in one function. But as I said, I mean, this is a possible way of doing it, but we want to formalize most of this work into reusable and more common building blocks. So while this is a custom way of writing this this new column, of adding this new column, encapsulate all that. Okay, so here we have another even more complicated example we have. So here we want to create a data set that contains names of Academy Award winners that were also nominated for were also winners of an Emmy, which is, I guess, it's interesting for some people. But so this is an example of flow that does it. So I'll sort of walk through the different steps of this flow, and if you have any questions, then I think it would be a good time to ask. So we start by loading from a checkpoint. So what is a checkpoint? Let's go back here. So two CSV files, one called Emmy CSV, one called Academy CSV, and it just stores. Eventually, it stores a data package. But after loading these two CSVs, we're calling a process called checkpoint. And checkpoint is a very useful thing when you're debugging, when you're working with sort of developing with data. You oftentimes use a read data from an external resource, and then you run it. You see that it's not exactly as you wanted it to be, and then you rerun it, and then you wait again for the resource to download. And it's very time consuming. And you always can add a cache or maybe download it locally, but it's always something that you need to do manually. So here in DataFlows, we have something called checkpoint, which is basically saying, okay, when the flow completes successfully, just store the data that was processed until this point in a checkpoint. A checkpoint is basically a data package behind the sort of under the hood. But I give this checkpoint a name, and then whenever I rerun the flow, and that checkpoint already exists, it will just load it from the local disk. It won't try to run the previous step. So if I have a checkpoint here, then it will just keep these load functions. It will just load it from the local data package. And if I have a couple of checkpoints, it will try to find the sort of the last one that has data. So to save as much processing as possible. If you want to reload the data, fine, just delete that checkpoint from your disk, and it will rerun all the steps once again. So we already ran this flow and point, and now we have that, so we can just use it as an intermediate result. And we call a processor called filter rows. It's again part of the standard library. We want to find in the emis all rows that has winner equals 1. We then concatenate the two resources. We want to concatenate the emis and oh, sorry. Here we have a step called concatenate. Concatenate is used to concatenate multiple resources. It's also used just to rename. So you can concatenate a field to itself and just filter out a few of the columns and maybe rename them. So it works with the multiple resources. It also works with just one resource. So we just rename the nominee column in the emis to be the any nominee, and next we use something called join, which takes the Oscar's resource and the Emmy's resource and joins them using a key, which is basically the field name from one resource and the field name from another resource. And by the end, we have a joined resource. So we took two resources, we joined them together to be one, disregarding all rows that don't have a match. Again, we filter them by finding those rows that have an Oscar winner. And eventually, we write them the results to a data package, and then we can just publish it. And also, obviously, print the results, and we can see a few names that I don't really recognize, some of them at least. So this is a more complex example of basically taking these different steps like concatenate, like filter, like checkpoint, like join, and combining them together to create a pretty powerful processing pipeline. Notice that I didn't have to write any specific, any custom code here. I just reuse the different building blocks and sort of combine them together to do what I want. And I've been running with these building blocks for quite some time, and from my experience, they cover about 80 or 90% of what people want to do. And then all that's left is the remaining 10%. So if I need to do a very specialized cleaning or normalization of data, then I just need to do that. I don't need to worry about the rest of loading the data or saving it or parsing Excel. I mean, that boilerplate is already taken care of. Okay, it's a good. And then I'll show you the CLI of DataFlows. But first, questions.
Hi, Adam, it's Brooke.
Hey, Brooke.
Hi, it looks really great. I love the function signatures for row and rows and package term and what they should handle. I love that. I was wondering about checkpoints and whether whether you can in the CLI say to skip checkpoints, or whether you just have to comment them out in code.
So at the moment, I mean, a checkpoint is pretty straightforward. I mean, just store something to a file, and then we'll just try to load it. And if you want to invalidate a checkpoint, you can just delete the file. But I guess that at some point we're going to add to the CLI some option to do that programmatically. I mean, since this is Python, it's pretty easy to inspect the flow, find the checkpoints, and then maybe provide some user interface or command line interface to say, okay, skip the checkpoints, clear all checkpoints, maybe even have versioned checkpoints. I mean, anything is possible here. At the moment, we don't have it, but it's a great suggestion that we're definitely planning. I mean, managing the checkpoints.
Cool. Looks like a good tool there. Checkpoints looks really handy.
Thanks. I'm even thinking, you know, when everybody's talking today about reproducible science, and when you're running sort of an experiment, right? You want to sometimes just store the checkpoints in a versioned way, so you can say, okay, that's time that I ran that flow at 1 p.m. yesterday. What were the results? And you might want to have that already sort of handled for you. Just having that memory of what were the results at a certain point in time. Okay, any other questions or comments, suggestions? Okay, someone wrote something in the chat. Okay, does it make sense to use these to document API wrappers? So I'm not sure I understand the question, David.
Yeah, is this working if I talk now?
Yeah, send you.
Yeah,
great.
okay. I wasn't sure. Yeah, so I think I asked this in some of the forums on frictionless data, kind of looking around where to encapsulate. So for example, we often are pulling data, medium-sized data from, like, for a specific date from some API, right? So and it might take some arguments, and usually we end up documenting the arguments. The arguments themselves are, in a sense, like data rows, right?
Mm-hmm.
You might call today, yesterday, whatever. So you give some examples, and then you have a certain expected output, and really that output's kind of a data package. And I've been trying to find the right spot in this kind of ecosystem to think about how to document these API calls. I know the API
Mm-hmm.
itself is documented, but it's totally heterogeneous how you document APIs, kind of, and
yeah,
it'd be nice for especially these data-oriented kind of calls to have a simple way to get towards what I would call a singleton call. So an example, like give a date, and you just call it, and it does something and gives you a data package. So I'm clear what that is. I just don't know where it fits in the ecosystem. So I'm wondering if it fits in here.
So I'm not sure I 100% understand the use case, but I mean, at least a few pointers. I mean, I think. So first of all, data package it's quite a flexible standard. I mean, that's what I love about it. So you have all those mandatory fields, but I mean, they're not a lot, and you can basically add any other field that you feel like. So for example, the API arguments, you can just add them as metadata to the data package. I mean, no one cares if you add more metadata to the data package. And you can have a very rich sort of description of what was the API endpoint and what were the arguments and when was the API called. You can have all that sort of as metadata in the data package. And the other thing I'm thinking about was you can define a very detailed table schema to sort of define what the results should look like. So if a parameter is mandatory, or if it has any constraints on the type or on the length or the pattern, you can define these things in a table schema. And eventually you can use the data flow to basically do the the querying of the API because it's just Python. I mean, you can just write a function that does it.
Yeah, that's what I'm asking. Is DataFlow the right, like, to put all that together? Is DataFlow a natural place at this point?
Well,
it sounds like it is. Right?
I mean, DataFlow was built originally for doing the like ETLs and data processing, but I found it's a really very useful API just to build data packages. I mean, I've been using the data package py, the data package, the official data package library, and I found that using a flow to describe the way that you sort of incrementally create a data package is more intuitive to many people. So you start by sort of an empty flow, and then you just add the metadata, then you add the different resources, and each one of the resources might get data from different places. So you can write a function that just queries the API and yields the results of the API, maybe extracts the results from the API in a specific way, maybe handles retries or whatever you need, right, for the specific API, and then just dump it to a file, or or take the data package and maybe send it somewhere else, or put it in a database, because we have also a dump to SQL, so you can just dump the data directly to an SQL. So I found it to be a really useful tool for taking data and validating it and just putting it somewhere. I didn't mention we have integration with something called Zinger taps, or Zinger IO. So we're also integrating with that, so you can just use a tap as a source, and we're going to add also using taps as targets. So you can just add them inside a flow and just use them directly. And Zinger Flows has already got like a ton of different sources, so you can load from analytics and different databases, and so it just works. Any other questions or comments? Okay. So last thing I'm going to show you is the CLI, which is, I would call it a work in progress, because it's sort of a proof of concept, but we're going to add to it a lot. So oftentimes, the place that you're stuck with is just getting started. And for that, we created a CLI for DataFlows, which is a couple of times you won't need it, but if you're just starting, it's pretty useful. It's a tool utility that you can just call it using DataFlows in it, and the name, a URL, or a location of a source file. And what it does basically is it loads the data and shows you what's inside. So it loads the data, tries to infer a schema, and just prints the results. This is what it does, but it has sort of a nice bonus, which is basically that while it's loading the data and showing you the results, it will also create a processing, a working Python file with all the code that was basically used to load the data and print it. So let's see the example here. I'm running DataFlows init with the CSV file. It's creating academy csv.py. It's running it, and this is what it does. It basically loads file and just prints the results. And if I want, I can just rerun that file, rerun academy, and it will just redo the same thing. Just the flow. I might even risk live demo. I'm not sure I want to do that, but let's try it and see if. Okay. So I'll share my screen. If it doesn't work, we'll just remove it. We'll remove this part from the webinar. But okay, so I'm just going to run DataFlows init here. Okay. Create a data package. I mean, it took the CSV to create a data package, so that was pretty easy to just package CSV master and frames, and it also rewrote the results in a standard way. So it's using the Python CSV library to write a standard UTF-8 CSV file. So that file into a path. You can import this and also use it as a command line script. And this is a great starting place for starting to tinker with the data. So you don't have to open your editor and start typing and trying to remember where was that import and what how to start. It just gives you that first step for you to sort of move forward with. Another yeah, so that's the gist of it. And I can also run DataFlows in it without it will just ask me what is the source of my data. Let's say it's in the URL. I'm going to put in the URL. It will ask me what I want to do. Maybe I want to filter according to some column values. Maybe I want to delete some columns. So I can basically do some processing here. Again, it's not a UI for like point and click sort of data processing. It's just a nicer way of getting started. We assume that anyone using DataFlows would be someone programming in Python. So it's not going to replace that. Let's say Academy. Okay, and now if I look at the flow, it added a filter here that I need to fill in the values, otherwise it won't filter any, just throw away all the rows. So that's the reason we don't see anything. So that's about it with the CLI. Okay, I have 2 more questions on the channel. Great, thank you. Yes, so if you go to, okay, the question from Sander is is there a public link to the tutorial? So yes, if you go to DataHQ DataFlows, and you scroll down, you get to the tutorial. So this is a tutorial in Markdown form, and you have like this button here called Launch Binder, which is a cool service that will just take the tutorial and just launch it as an IPython notebook on the cloud, so you can tinker with it and modify the examples and rerun them and see what you get. So this is a really an installation-free way of playing with the library. And second question, tutorial looks like this stuff.
That was just my attempt to answer.
Yeah.
Sorry about that.
Yeah. So this blog post is exactly, I mean, it doesn't look like it. It's just a copy paste of it. So we just published the tutorial as a blog post. But I think it's more fun to play with it in an IPython notebook. I mean, just playing with it and just maybe trying to write your own function and see how it works is more fun than reading a blog post. With all due respect to the author of the blog post. So yeah, that's the tutorial. I'm also building a website that will sort of contain the tutorial as well as some useful how-tos, how to write a scraper, how to integrate with IPython, how to integrate with pandas. And this is something that we're going to continue working on, because I mean, you read a tutorial, but sometimes you get stuck with a specific use case, and I'm going to collect these specific use cases and try to write sort of like best practices on how to work with that.
Hey, Adam, this is Adam. Can you hear me okay?
Yeah.
Hey, this was really great. Thank you so much for taking time out to show us this. I had a question here about the command line interface. Are there any switches that would help us, or pre-configure the boilerplate to say do things like infer types on tabular data columns or anything like that?
So the CLI. Let's try to answer it in two different levels. So most of the heavy lifting of loading data from external sources is done using a processor called load, which is in turn based on tabulator and the tabulator library. And load, basically, you can pass it any parameter that tabulator knows how to work with. You can just give it to load. So if, for example, you're loading from an Excel file, load will accept a sheet and will accept headers and will accept 4 strings for loading data from Excel as strings. What load gets is a name, which is relevant, which is basically saying when you load the data, name the resource with this name. It gets a resources. Hold on, I'll try to reshare my screen. Sorry, I'm showing stuff to myself here. Okay. Okay, so I'm in the API reference for DataFlows. It's coming from the README to this page. So I said there's the source of the file of the data that we're loading. There's the name of the resource that is going to be generated. Resources, in case we're loading from a data package, then we're just going to specify which resources we want to load. And finally, there's a validate, which is really useful. Sometimes you want load to validate the data while it's loading. Sometimes you don't want to do that. You want to sort of tinker with the data, modify it, clean it a bit before going and validating it. Data will always be validated in DataFlows when you dump it to a file, or when you print it, or when you just call a processor called validate. So data is validated. I mean, the types are not just for they're just for shows, that they are actually used to validate the data. But you can control whether you want to validate it in load. But you ask about the CLI. So the CLI is a bit, I mean, it already has functionality, but you can't really control all the different switches or all the different processors inside. And this is something that we're going to add eventually. CLI is based on basically on a sort of a template that is filled with some configuration, and at some point we're going to add that option to the template. But I think that eventually, I mean, people using data flows a lot will eventually prefer not using the CLI to create the flows for them, but actually maybe use a more custom Python code if you want to generate flows.
Yeah, that's great. Thanks so much. Appreciate it.
Yeah. Does anybody want to hear about integrating data flows into data package pipelines? We're at time, and I can talk about it for a couple of minutes. So if you want, just write on the chat, and if not, then...
Adam, I would definitely be interested in hearing about that.
All right. Yay. Okay, so cool. So, all right, so I'll talk about it a bit. So today we released version 2 of data package pipelines, which is, as I said, it's sort of a refactor of data package pipelines to use data flows instead of the data package pipelines processors. I can say that almost all of the API remain the same. I mean, because data flows is sort of conceptually built with data package pipelines in mind, we didn't change the API a lot. But I can show you how a processor that inside a data package pipelines pipeline. One way is to, instead of writing run, just write flow. And this will try to find the Python file that is referenced by the name here. So we're trying to find a Python file called myflow, and we will try to import from that file a function called flow, which looks like this. It accepts four arguments, parameters, data packet resources, and stats. And that function is supposed to return the flow. So this is sort of the contract. And if you manage to create that function and return the flow will be wrapped in a special data package pipeline processor that loads the data that's coming from the input, pass it to the flow, run the flow, make sure that the flow is complete, and then the output is again streamed to the next processor in line. So this basically works. So you can load the resource in a data package pipeline processor, then run the flow like so, which does some sort of multiplication, and eventually dump to path in again in the data package pipeline processor. This is one way of sort of embedding a flow inside a pipeline. There's a second way of doing that, which I'll show you an example of it in a sec. So let's take, for example, attributed field has specific code that handles parameters and added fields based on a specific set of operations. You could add a constant field and a field that's a result of a multiplication of other columns, etc. It's not really relevant. So how does it look now? So this is the entire processor. We use a utility function called spew flow, which basically gets a flow from a function. It doesn't. I mean, the function that is not doesn't have to be called flow, but it's just for as a convention. It's useful. So it receives the flow and the context, which is something we get from ingest. So this is a really common pattern that's you could find it in the data package pipeline source code quite a bit. And that flow that it gets, it only has one step, which is the data flows at computed field. So we just sort of redirect all the processing to that DataFlows processor. We give it whatever we find in the parameters, and it's pretty straightforward. So if you want to just wrap your flow inside inside a processor, a regular processor, for example, you want to create sort of a dual DataFlow/data package pipelines extension. This is the way to do it. This is the processor, and you just embed that specific flow inside. So I hope that was clear. And if you have any questions about that, then I'm happy to help.
That's brilliant, Adam. Thank you so much. I think that was the nugget that we were looking for. So this is great.
Right. So if you have any other questions about this, then I'm available in the channel as well as on Twitter, email, and you know where I live. So just find me, and I'll be happy to help.